In this video, we are going to do problem number 30, merge. All right, so in all the previous videos, we did them at lockstep, right? So we processed two lists at the same time in sort of this lockstep fashion. We did process only one where we ignored the other one. And now we're going to process both of them, but sometimes at different rates, right? So like so. And the recursive call is going to look something like this, where we have some condition and we process the second one, and then the first one stays still, or the first one moves, and then the second one stays still. All right, so I already have merge downloaded and opened up in Racket. So if you scroll down, let's get started with the problem statement. So the problem statement says, design the function merge. It consumes two lists of numbers, which assumes are each sorted in ascending order. It produces a single list of all the numbers also sorted in ascending order. Your solution should explicitly show the cross product of type comments table. So this table over here, right? Try to write it down like so, right? Enumerate all the possibilities where both lists are empty and list one has items, list two is empty, and etc. All right. Let's see. Your final function should have a cond with three cases, so you can simplify towards that later. You can do the simplification using the cross product table by recognizing that there are subtly equal answers. All right. So for example, assume both input lists are sorted. So we have merge of list 47 and list 169. So both of these we assume are sorted, and they are sorted, right? 4 is less than 7, and these are also sorted in ascending order, right? 1 is less than 6, and the 9 is in front of this 6. Notice how the lengths are different size, right? The length of the list. This one is 2 long, and this one is 3 long, right? So it's not going to be like the previous video for lockstep processing where we only need to check one of the lists during simplification. All right, so this whole thing should produce list 1469 because 1 is the smallest number, 9 is the largest, and all the numbers in between are sorted. Hint, think carefully about the values of both lists. You might see a way to change a cell content so that two cells have the same value, right? So given this table, we can actually merge some of the cells if we simplify it later. All right, so pause the video and try to do this on your own. Try to do merge on your own. I'm gonna go with spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing in it. So now let's go over it together. So signature merge consumes two list of numbers, which we assume are sorted. So two lists of numbers, so that's the first one, second one, and this whole thing produces a list of numbers. All right, so list of number. All right, so purpose merges the two sorted lists into a single list with the numbers in both lists in ascending order. All right, signature purpose, let's stub this out. So define merge, let's call this L1 and L2 for both of the lists. We have to produce a list, so let's just use empty as the dummy value. Okay, so now let's write some tests. So elaborate some examples over here. So merge, let's see, looking back at our table, let's see all the possible combinations that there are. So if both lists are empty, what do? Well, if both lists are empty, then we should probably produce empty. All right, because that kind of makes sense. And let's see, if list 1 has items and list 2 is empty. So I'm just going to copy and paste this. So if list 1 has items and list 2 is empty, so this is list 1. So we're going to say list 9, 4, all right? What should this produce? Well, we should produce this in sorted order. And again, the problem statement says that you have to assume that both input lists are sorted. So this doesn't even make sense because it's not a sorted list, right? This requires that you assume that the lists are already sorted. So this should be 4, 9 instead. All right, so make sure you get your test right because it will really help. All right, so for the next case, list 2 has items, but list 1 is empty. All right, so list 2 has items and list 1 is empty. We can swap these two. So you're going to be list 2 and then list 1 is going to be empty. So this should produce list 4, 9. All right, so both of these actually should produce list 4, 9 because even though the second list here is empty, right, we still have to produce a sorted list of numbers, merging this list with this list, even though this is empty. So this should produce list 4, 9. And for confusion, to reduce confusion, let's just make this, something like 7 and then 8. 7, 8, because that is sorted. So this should produce 7, 8. All right, so now for the final case over here, which is if both lists have items and they can be kind of arbitrary, right? Like list 1 can be too long and list 1 can be too long and list 2 can be 3 long. All right, so let's actually copy and paste this test below. Why not? Check. Expect this should produce this. Control I to indent, and we can also swap these two if we'd like. So this can be in the second place, like so. So that gives us a good range of tests, and we are good. We can write some more tests later if we'd like to elaborate this if we're stuck. All right, so let's just run against the stub here. We get some differences, but no syntactical errors. So you can comment or delete the stub now, and we can grab the template. All right, simultaneous recursion template. You can write this manually or get it from the website. So I'm just gonna get it from the website to save time. This is going to be renamed to merge. And let's see, we already have the signature. All right, so hopefully this should be all the mental scaffolding needed. Really pause the video and try to work through this on your own. I'm going with spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it, so now let's go over it together. So looking at this first test here, if both lists are empty, then we should just produce empty. So there we go. That is done. Now for these other cases where one of the lists has some things in it and the second list is empty. So given this, list 4, 9 and empty for the second list, we should produce list 4, 9. So we have the template here, and let's see, we have to produce a list of numbers. So we can make a list by using cons, all right? So we're going to take the cons of the first list. So this is test here again, and we're going to get that 4. And then this is that 4, right? What do we want to do this for? Well, we want to slap it onto the other elements. So we're going to have to wrap this into a recursive call over merge. And then this, we're going to go take the rest of LSD1. So that is correct. And then LSD2 is empty, right? This is this case, right? So we don't really have to do anything to it, right? In fact, it's an error if we probably do anything to it. Because if we call rest and it's going to blow up, and if we call first, then it's not going to work out either. So that one stays the same, right? Likewise, it's like the same with this test, but reverse, right? This is this test over here. If the first list is empty and the second list has stuff, then produce the second list, 7, 8, right? Produce the items in the second list. So we're producing a list, so that's cons. And this is going to take the first of the second list, right? So given this test, it's going to be the first of the second list is 7. This is the first list, this is the second list. So we want 7 in the output list, along with the rest of the other numbers. So we have to do the recursive call to do the rest. Right, so merge. And then list 1 stays the same, so LST1. And then the rest of LST2, that's the recursive call, like so. All right, so that's 1, 2, 3 tests knocked out. Now comes the hardest part, the final test. All right. So for the final test over here, we have 2 cases. One where the second list has the lower item, right? This 1 is lower than 4. So the first item in the second list should be first. And then the first item in the second list should be second. And then like so, right? That's one case. The other case is if the first list has the smaller number, and then the second list has the second smaller number, right? Like so. All right? So these two zigzag, and there can be a case where they don't zigzag. And yeah, but nonetheless, right, this kind of indicates that we need an if, because sometimes the smaller numbers exist on the right list, and sometimes the smaller number exists on the left list, right? List 2 and list 1. So it kind of indicates we need an if here, all right? If. So what are we comparing? We're comparing the first of the 2 lists, right? 4 and 1. So we're going to wrap these 2. This is going to be 4 and this is going to be 1. So we can imagine that. We're going to do something with them. All right. And if has 2 cases, true and false. And we can come back to that later. All right. So what do we want to do here? Well, if the first item is less than the second item, right? Then that's going to be, let's see, the first item is less than the second item. This is going to be if the first item is less than the second item. 1 is less than 4, so we want the first one of the first list to be the first in the upper list, right? So we want to stick whatever numbers you are in front of the second list. So we can just write that out, right? So we would need a cons because we're building a list, we're producing a list. So this is going to be cons. We're going to grab the first list because we know based on this condition that it's smaller than the first item in the second list. And then we want to continue on with the rest of the list. So we're going to call merge with the rest of L1, like so. And then list 2 stays the same. All right. Because, you know, we compared them, but then in the next iteration, it has to process the next one, right? So first, this is going to be this case 1 and 4. Let's see, 1 is smaller than 4, so I want you first. I want you in front of the merge onto the 1. We just processed the 1, but we don't know if this number and the next number from the first list, right, is smaller, right? So, so that's why we only do the rest on the first list, not both of them at the same time, right? Otherwise, it's the other way around, right? Otherwise, the second list has the lower number, and we want to put that in front. So it's going to be that second list, the item on the second list, we get that by calling first, and then we call merge on the rest of the second list only. All right, and we can delete this like so. All right, let's just run these tests, and looks like there's some difference over here. 169 and 47. 169, that is sorted. 47 is sorted. Oh, looks like the 7. Okay, I forgot to write this 7 for some reason. All right, so 1, 4, 6, 7, 9. There we go. So the tests were wrong. My bad. All right, so now all the 5 tests do pass. All right. So now test, review, and refactor. So looking at these tests over here and looking at the code, this test over here, where the first list has things in it and the second list is empty, we just produce the first list, right? This is this test, this branch over here. We produce the first list and we don't even touch anything the second, right? We don't call rest on the second, we don't call first on the second. So we're building the first list kind of all over again, right? If the second list is empty. So why don't we just produce the first list, right? Instead of building the first list, just spit it back out. So this is gonna be list 1, right? So if the second list is empty and the first list has stuff in it, then hey, just produce the first list, right? So we don't even need to check this case over here, all right? And let's see if I jump to this. Oh, it says and expect 2 arguments, so we can just delete this. And that is that case over here. And we can do the same for the second case, right? This second test here, which is going to be this one, right? If the first list is empty and the second list has things in it, then we're rebuilding the second list, right? We didn't even touch the first list. Instead of rebuilding the second list, right? We can just reduce the second list and ask, hey, if the first list is empty, and I have list 7, 8, just spit out the second list because it looks like we're not doing anything with the first list anyways. So that is this second case here. All right, so delete this and delete that check and then delete this and. All right, so we just run this code. Looks like all 5 tests do pass and we end up with some more simplified code. All right, so do we need this and over here? This checks that both of them are empty, right? But if one of them is empty, then it's going to hit one of these cases, right? So if one of them is empty, this test over here, then it's going to produce the first list, right? So if list 2 is empty, then produce the first one, which is also empty. And if list 1 is empty, and yeah, we just produce the second, which is empty. So we can sort of factor this out. Let's just try it. Right, so delete that case, and we can see that we merge that into these 2 statements. All right. And lastly, since this last case, right, is the last case of a con, this can just be else. And if we run this code it still works fine. All right. So we went from a 4 case cond. So just undo all this actually. Actually, let me copy this and then undo. So then I can paste it back so we can compare and contrast. So this is what we had earlier. Something like this. Right. And then we went from this to the simplified version where we deduced that, hey, these 2 cases and this one is already covered by these 2, the factoring of these 2. Right, so we went from a 4 case cond down to a 2 case cond. That is arguably a little easier because we can just look at, because the conditions are also easier, right? Like so, rather than reading this. But again, right, just do this expanded version to get some working code and then do the table method, right? Write out the values in the tables and look at, hey, right, what is the same over here, right? Like so, and delete things and try to merge things together and make sure that they pass the same test so you get the same functionality. All right, so you're gonna have to replicate this sort of line of reasoning for the 30 point problems, right? So there's only one other one, and I'll try to add more for you guys to keep doing until you guys are comfortable. All right, so submit this in two-handed and check your score. And that is about it for this one, and I will catch you in the next one.